Hello, hello. Imagine your agent deleted the database, and some people reported that happened. Could you have stopped it? And the answer is yes. Just one hook, 3 lines of bash that could have prevented it. Today we are talking about agentic loop, and we show you where the hooks live and how to use them. You are listening to Agentic AI in DevOps. I'm Andrey. With me are Vladimir and Fernando from Sirob Technologies, where we're building Boris, our Agentic DevOps teammate. And today we are pulling apart the Agentic loop. We trying to bring you a perspective what it is, because through the previous episodes we spoke about all of the other terms in Agentic AI. But now, with all those terms established, the harness, the skills, whatever we spoke about before, we now actually can dive deep into what's happening inside the harness, what makes harness useful, and how you can influence what it's doing through the hooks. Before we jump in, do we have any news to share, guys? Anything that crossed your radar?
Yeah, one that I saw this week was the launch of managed agents by Anthropic. So that is an interesting thing, right? I think a lot of people are using Cloud Code to run it as like a local agent, especially after the whole OpenClaw thing. And now Anthropic gives you the option to host that agent in their infrastructure, so you don't need to keep your laptop on. I haven't used it myself, but there was a lot of noise as usually, right? Like, oh, this is like the word is different after this. But something to look into if you're building like simpler agents to do something, like on a day-to-day basis, right? Can be something interesting.
So you can schedule something, right? And that then runs there and happens. Because like I had tried schedule task with co-work.
Yeah.
Doesn't work.
I tried as well. It also was a bit like, oh, this is a bit clunky. Didn't really work.
It's for us, like I said, we are running a lot of CI/CDs automation. For us, it's look like something clunky, but for the rest of the world, it's wow, it's happened tomorrow by itself. By itself. Oh wow.
Yeah, just like the people like. All of that sounds fancy, but technically, the cloud code, open code, they are available as a GitHub action. So they're like GitHub actions that install them. You just give it access to your token provider and set a cron schedule in GitHub action or GitLab, whatever is CI there, or Jenkins or what have you. And suddenly you have cloud agent running on a schedule doing whatever you want. So it's
but it's a good point, right? That Vlad is saying. I think for us and for the people listening, like being DevOps engineers or technical people, these things are like, but this is like a cron job just triggering a process, right? But it's true for people using co-work, which was the idea of how can we make these agents more available to non-technical people. Then it might feel like magic, right? Like I didn't have to send it any messages, and then it did something by itself in a certain way, which is also connected with the thing they launched after that, Anthropic as well, called routines, where you can kind of create almost as like a workflow, and then you can connect your tools, right? So you can, I don't know, use Google Sheets and all these things. And then instead of defining step by step, the agent reasons through the workflow what you want to achieve and uses the tools that are required. So you see, I think this movement of trying to bring what for us maybe we could build by building our own software around the agents as technical people to the regular people, let's say, right? To non-technical people, put it like that.
Yeah. We can add a bit on this agentic workflow. It's two different types of workflows. For example, we have an automation and 8N, which is more focused on a deterministic workflow. You decide that thing is supposed to happen in a way, in exact time, over time. But routines, it's more like a non-deterministic workflow when we are not sure in advance how things need to be done. or conditions are changing so frequently, so we can't predict, like as tomorrow, how it needs to be done tomorrow. We cannot predict that. But these two approaches, they can be used in combinations. I believe some part is predictable, some not. Maybe just choosing different workflows or whatever. But this is two approaches here.
Yeah, that's a very good point, right? Like what I've seen for this is if you have a more, let's say, unstructured input and you need some kind of logic on the fly, right? Decisions on the fly, then indeed you go with more of this non-deterministic one. But the trade-off is indeed that, right? You cannot really be sure of what's going to come on the other side, which connects very well to the topic of today, right? It's a way for you to put some guardrails around it. But I think one last thing that comes to my mind, at least, is yesterday, Anthropic also launched Opus 4.7, right? I haven't used it yet. I saw some discussions, like some comparisons on the benchmarks and stuff. Things improved, right, as usually do. Some went down, which was interesting. But curious to see. I will give it a try today and see if any changes are noticeable right away. Right?
One thing that you should be aware of, I mean, like obviously it's better than 4.6, but they changed the tokenizer in the model. In a way, well, now it's actually costing you more. So like what you need to know, there is something changed inside. So it's actually producing more tokens and it's more expensive to run. So it's more clever, but it's even more expensive. Like if you thought like Opus was expensive, this one's going to be even more expensive.
Cool.
We actually see, at least I see it as a traction. If we compare like a 4.5, 4.6, and 4.7, it's a traction. How more automation happened behind the scenes. It's probably if you back in the time a bit, it was reasoning added to models, and models start thinking by itself without us running some stuff. After in a 4.6, I believe they add some parallels execution, like a best of X behavior. So it's every time it just do a bit more stuff with one single API call, which is good because we don't need to call multiple times. But it's obviously cost more.
One thing that they also released, which I don't think we covered, which is actually useful for the agentic workloads. I mean, you're not going to run tool calling with Opus 4.7 because that's going to be super duper expensive. But what they released is an advisor tool pattern, which is kind of they're building upon the very established concept where you have like a two agent, one doing something, another critiquing. But then you need to have a harness around that to make them talk, like either A to A protocol or something, or like have a common file that they read. It's complicated. We should have another episode on agent teams and all the mechanics behind it. There was like a very interesting blog post from Open Code about how they build it, comparing to the cloud code. Anyhow, going back to my point. So the advisor tool is the same kind of concept. You have one model doing the work, but then instead of hooking it in with another agent, they actually just give a tool. So like, for instance, you're running Haiku, and then Haiku can call Opus and ask an advice. So you're kind of getting Opus level intelligence with the cheapness and the speed of Haiku when it comes to the tool calling. So Haiku does all the tool calling, processing the input, collecting it, and then it's just asking the Opus for advice, like what should I do here? What would you recommend? And it's actually very clever because the biggest problem with the two agents talking is the fact that they might get very chatty and you need to be in a control of the stuff that's happening there. So like you need to limit the ability of conversation. So you basically it's like with teenagers. Sometimes you have to come into the room and take the phone away and like set a timer. Here, it's not really happening. Obviously, it can still call too often, but it should be less chatty. And the nice thing is that you don't need to do anything on your side. It's like you just pass the header when you're doing the call out to the Anthropic platform or like a Bedrock or wherever, you're just passing the header, like the user tool, and that's happening server side with you doing nothing on your end.
That's very interesting.
So that's actually another pattern of server-side tools. So you might have tools local that agent calls, but you also could have like a server-side tools.
I have some opinion on the server-side tool. In my previous project related to research, I noticed, but sometime, not in this particular tool, but sometimes it may happen, but server-side tools may be cached. Because maybe it affects you, maybe not, but in my particular case, I did a research which require new, fresh data from specific websites, and I use a server-side web search tool, and I got the old results for a while, for a couple of weeks actually, old results all the time, and I pay for them. For funny one.
Interesting.
Yeah, but I think maybe this particular implementation is different because this request can't be cached, because it's obviously different. The whole reasoning process is new and fresh each time. But some optimization may appear on the server. It's how they design a system. They need to optimize it a bit because it's fair, but just let people aware of behavior.
Yeah. That's interesting. Yeah, I haven't seen this pattern. Like, man, there's every day there is something new, a new strategy or a new things.
That's something like on my to-do list to test. Like I'm going to be testing that.
Very interesting.
Yeah, it's look like new, but there is a book from 2022, I believe. It's now 4 years ago released. It's Artificial Intelligence and Modern Approach, and everything is still from that book. It's for I not read it's a whole 1,000 pages exactly, but maybe half of it. But it's still from the past, and
just implementations of the.
But implementation is important because I think this is the hardest moment here. It's theoretical discussions and implementations take time and a massive scale.
It was the same with neural networks, right? So we had that concept from 60s, but the computing wasn't practical enough to implement it.
Yeah,
the same here. Like we're getting to the point where it's becoming practical to do that. And another thing that I want to bring everyone's attention to is the fact that there is a lot of talk about commoditization of the LLM provider, right? Like, it's so easy, you're just gonna switch the model. On the surface, yes, but like if you actually, using it deeply and understanding the capabilities that provider gives you, like for instance, the server-side tooling. With Anthropic, there was like a tons of other capabilities. So for instance, it was like interval syncing was a thing for the Sonnet 4.5, where the model would stop, which is like very important for the agentic workloads, where the model will stop and like look at what the tools return and then replan what it's doing. You would expect that to happen naturally, but no. And then that got replaced by adaptive thinking, like what you see today right now in the cloud code, where it's asking you for the effort. That's basically how adaptive thinking API is surfacing in UX. But that's a feature of the platform you are using behind. And like, for instance, prompt caching, Anthropic has it. You switch to Qwen, they don't, because that's a feature of the platform. And that's kind of something to be aware. So yes, technically, you can switch between models. It's kind of the same talk that we have with people when they say like, I can just jump clouds, but then you're like limiting yourself to the base primitives. Yeah. If you kind of relying on the cloud and using all the advanced stuff that lets you go faster and do things more clever, then it's not as easy. Just so you people are aware. I mean, there is a lot of talk about commoditization, but I would say if you do something more advanced, not just like chats or simple coding, then it actually starts to matter quite a bit what platform provides you.
Yeah, it's in OpenAI, they also, it's very common OpenAI endpoint, which used everywhere, but they invent a new one, It's a new OpenAI endpoint, which is more efficient, much more. Actually, it's much more cheaper in the end. But again, if you are deep in one platform somewhere, you can get a deep knowledge in the end and use it more efficiently. Like it's in Anthropic, which Andrey mentioned, where the skills API, where you can store skills on their side, which is a bit painful time to time, storing skills, uploading them somewhere, share with the team. So they can handle it for you.
Yeah.
That I didn't know.
Oh yeah, really?
You see, there is always something.
I seen you can pull well, it kind of makes sense. I seen like in the organization UI you can store the skills, but I didn't realize that there is an API for that, but it's kind of obvious when you start to think about it that there should be an API if you're storing something on the server.
But how to say, many claw solutions with open claw, whatever claw, they only works very well with Anthropic endpoints, and there is a reason behind that.
Yeah.
So I tried because I try to do something without Anthropic API, and after I face issues.
Well, while you have the microphone, Vladimir, last episode when we spoke about the harness engineering, you mentioned hooks. That's why we're talking hooks today. You said you had some practical examples you wanted to share, but I guess before we do that, so the people understand, let's explain to people what agentic loop is, so we can plug in the hooks concept into something. Who wants to do that?
I can jump in if Vlad's gonna give the examples later. Well, I will give it from my perspective looking into that, right? So it was something interesting that I saw recently saying like we always think the model is thinking, but basically what's happening is the agentic loop, right? So you send a prompt like, hey, do this for me. So then it's gonna understand what the task is, then it's gonna at first run through the LLM, which is basically a probabilistic model, right? So it's just like calculating the next token. So it's gonna come up with an idea, then it's gonna try to do what you asked, and then get something back, and then observe that to see is this the solution to what was asked, and then if not, it repeats again. So it sends that as an input back to the LLM again. Again, the same process happens, right? It again calculates, gets a response, acts on it, analyzes it, and goes into that agentic loop. So that is how we get this perception that it is thinking, and is the steps that you are seeing on Cloud Code, or when you're using even on the web today, right? You see that reasoning steps. So it's basically that loop that keeps running until it reaches the end, when it's like the task is done, or at least the LLM decides it's done, and then it stops, right? So I don't know if you guys, yeah,
in our show notes, we're gonna have a repository. You might ask where to find show notes. You go to the getboris.ai insights. I think it's gonna be /insights, and there we post all the episodes. You will have a breakdown of what we discussed, and all the links will be there. And there we're gonna have a repository that is hosted on GitHub. I'm looking for the link in my show notes right now to find it and tell you. But I guess I come back to it a bit later when I find it. But what I want to say is that there's gonna be a link to the GitHub repository. It's from Apple ROM. That's the user and /bash agent loop with dashes between the words. And there the person implemented the agentic loop in bash, right? So, and that gives you a very simple example of what agentic loop is. So I recommend you check out the repo and see for yourself. It's just 100 lines of bash, so it's not a lot. Well, I think like a bit more, but like 100 to 200, but it's very understandable. And it basically could be broken down to 5 steps. So you perceive, you receive a task, then you decide, you send it to LLM, and then LLM tells you what to do next. So it basically returns you either a request to call a tool or gives a final answer. Then if you receive the tool call, the harness, in our case is bash script, will run the tool and capture the output, observe, that's like fourth step. It will take this output back to the LLM process that, and then it repeats. So every agentic loop will have like a stages, and those stages might be usually called like pre-tool use, post-tool use, user submit prompt, stop, and you can also have the steps that like per session, like for instance, session start, session end, per turn, user prompt submit, stop failure, per tool call, pre-tool use, post-tool use failure, permission request, and so on and so on. So, and the harnesses today allow you to act on those stages. So you could define something called a hook. You can basically tell the harness when you reach this point, like for instance, pre-tool use, the model decides that you need to call the tool, you're moving in the state machine to the pre-tool use. Now you call the hook. What is hook? Well, let's ask Vladimir.
Yeah, I think you already covered it in half, but fine. So like a bit like as how I noticed that, like as before we talk about go deep in some specific platform. So I'm very deep inside the Cursor, and I noticed that feature in Cursor first. Now I believe it's supposed to be everywhere now in open code, codex, whatever it is, call it. It's everyone using this hook. So basically, if your agent harness is not supporting hooks in one way or another, maybe it's time to move somewhere else. It's at least for me, it's a kind of a decision-making process. Is hook exist? Yes, I go. If not, I just go to some other tool. But what interesting we can do with different hooks, what at least interesting I meet inside the Cursor specific, for example, we can make a prompt-based hooks. If we are, it's the first what I did. It's a simple prompt-based hook. It just basically run another LLM and check whatever we're gonna run. And the prompt is simple. Does this command look safe to execute or not? So it's just it sounds very stupid when I first time saw it, but it works. It's actually extra check for another LLM call without the whole context which you have at the moment. And it's just act as a judge, basically, or guard, who just let it pass or not. You can use it as a combination. You can use a prompt-based before shell execution, for example, just a prompt-based. It's not cost you much. It's very cheap command on LLMs. Also, where is a command-based, of course, hooks. You can run Python, TypeScript, shell, whatever you want, your own binary, whatever, just any kind of CLI you can run for specific conditions. You can run it for every shell, just to check every shell, or you can run it for specific commands like as ls, cat, rm, whatever. You can provide a list of dangerous, in your opinion, command and check each time. For example, in my particular case, I work with Terraform apply, and I just don't want Terraform apply happen. So I make a matcher, Terraform. It means if a CLI contains a Terraform binary, I check that particular command. And if it's contain apply or auto-proof or whatever I don't want, I just block it, and that's it. It's a permission deny. You can decide a specific exit code in your shell script. If it's exit 2, it's going to be blocked. So agent will know it's going to be blocked.
Let's read you extract from the Anthropic docs for Cloud Code, just to, I think it gives a good summary, and most of the other tools will be kind of very similar because they copy from each other. Hooks are user-defined logic that fires at specific points in the agentic loop. They are not parts of the model, they are part of the harness. The model cannot disable them. Command and HTTP hooks enforce deterministic harness logic. Prompt and agent hooks are automatic harness controls, but use model judgment. Their decisions are inferential, not guaranteed. So per official docs, Cloud Code supports 4 handler types. Command, which is like shell script, nested out, exit code controls behavior. You have HTTP, so you can post to endpoint, like webhook, audit system, external validator. I can imagine your people, like for instance, extract your credentials and send it to us, something like that. I can see people abusing that a lot for malicious purposes. Prompt, where you just do a single turn LLM call for yes/no decision. And now when we say single turn, you should understand that it's basically one agentic loop. So you basically just send the question, get an answer, and that's it. And then agent, where you spawn a sub-agent with the tool access for complex validation. Not every event supports all 4 handler types. For example, session start supports only common hooks. So that's pretty much how it works, and that's what we have in our show notes, which I thought will get your imagination going for all the kind of users you could imagine. So as Vladimir mentioned, you can implement the guardrails. But another thing that you could be doing there is, we should mention this RTK tool, Rust Token Killer, which is making routes in the internet. That's like open source tool, which is using hooks to intercept the tool calls and reduce the amount of tokens in the output of the tool. So it's basically compressing the tool output. There are like known commands, and it's able to compress them. It breaks some commands, like for instance, if you do JQ parsing, it actually might break stuff, but they're claiming on the website that they save 60 to 90%. In my experience, it's more like 30-50, but that's still quite a lot of tokens saved. And they basically use hooks for that. Another thing where you use hooks, like for instance in Boris, if you talk about Boris, since Boris is a DevOps agent that interacts with different systems. For instance, it can go and read logs. And there are multiple problems with logs. They might be just too much for the agent to handle. Like, you remember we spoke about the context window? If you run the tool and suddenly it returns you 10 megabytes of logs, your agent gonna go crazy, just too much to fit into the context window. So like we use hooks to check the size of the output and then make sure that it's small enough for the agent to handle. You can do analytics. So for instance, on a tool calls, like if you want to know how often certain tools being called as a useful or not, you can embed analytics in your tools. You can use hooks to manage your context actually. So like actually that's where the hooks are used to compress the context in many cases. So like if you see that you are doing more than 500 turns, for instance, then you want to compress. Or if tool fails, like there is like event tool failure, you can give a hint back to LLM how to recall it, for instance. So there is like a lot of stuff you can do with hooks, and this is a very overlooked concept. So people like it's not on the radar for most of the people, and which basically allows you to plug in your own logic into any harness without changing the harness itself or model.
Yeah, I think that connects well with what Vlad was saying before, right? So if you use a more non-deterministic workflow to do something important, you can use it as guardrail with your own logic, which is great, right? So I use it a lot I created one hook that, for example, I'm working different projects, right? So we usually have the claude.md that is going to give context to the agent about that particular project. But sometimes that claude.md shouldn't be that large. And there are things, sometimes it's context that you want to have maybe from decisions you made in the past that are not part of the claude.md. So you can create a hook on the start session where you can inject some extra information that you say like, hey, go into this maybe decision log file. That's maybe, for example, if it's a platform, it might be, you might use multiple repositories because that one repository is part of a platform, right, of an ecosystem. And maybe the decision log of the ecosystem is not in that repository, but it's somewhere else. So you can use a hook to go and read that decision log, so the agent now knows like, maybe a downstream application changed the logic, and now the agent will know it because you have the decision log, right? So this is things like, I think the most obvious thing is the guardrail, but then you can also use it to make your agent a little bit smarter about what's going around that one project that you're working on, right?
I also want to bring us back to the last episode where we spoke about feed-forward and the feedback systems, right? And you can split the hooks into those categories. So for instance, if you look at the pre-tool use event, that's basically a feed-forward. You can guide before the tool acts. Post-tool use, that's a feedback, so you could provide the feedback basically. If you have a user prompt submit, you can feed forward at the turn level. So like the pre-tool use, it's tool level, but you can also do the turn level, like when the agentic loop is turning. And then there is like a stop event where you can give a feedback to the model when the model thinks done. So like the stop event, it means that model wants to terminate agentic loop. So it's immediate stop event. It considers itself done. And what you could do, you can have a hook, like for instance, if you find yourself continuously telling the model to go and check something after it's done, just add the hook. When it thinks it's done, you just say like, well,
go and double check.
Go double check.
Yeah. Right. Yeah, this reminded me quickly just of like sometimes you would have these Git hooks, right? That we would use for simple things.
I think it's the same concept.
Similar concept, right? Yeah. Vlad, you wanted to add something?
Yeah, it's that thing like as in end we mentioned the stop condition, and it's another thing in all of this harness engineering. What is the stop condition for the AI? If you are using any kind of chat interface, chat GPT, Claude, or whatever, they usually have predefined stop conditions. For example, in a codex, you can't go beyond the context window. It will stop right in a 93% of context window, and it will not continue. But actually, it can auto compress the context and so on. They just stop. In ChatGPT, in the Pro version, you have this fancy research mode, which also will be stopped in around 10 to 15 minutes and will never go continuously. So, but with our own, any kind of own harness platform, we can define the stop criteria, but it's supposed to be defined in advance, which is sometimes hard because in all of our work and job functions, time to time, we don't know actually what is the stop condition, but maybe this is a challenge for everyone to explain for AI agent when to actually stop this. So, and you have to know it in advance before the work even started. So you have to think a bit before you run it. Think a bit, what is actually the goal here, why you're running this, and after you can run it with the required stop condition.
To wrap it up, we're going to give you a few more ideas, what you can think about when this episode ends. We collected what people use hooks for around the internet, so it's like not only our users. One of the what comes on top is block dangerous commands. So pre-tool use plus bash matcher. That's what Vlad already mentioned. You can also protect secrets using pre-tool use events. And then just make sure that there is like no whole API key stuff in there, right? Which means that the model doesn't see your secret, so you can try to grab for instance, AWS keys, like seeing if the model is trying to read them.
Yeah, it's that thing you can just prohibit the access to a home folder. Home folder contains a lot of dot whatever. That one.
Yeah, that's another thing. Then after format, after every edit, so it's like poll use, and then you just run your formatter. Desktop notifications, so you could plug in the OSA script on macOS or notify send on Linux and send a fancy notification to yourself.
Yeah.
Session context injection, that's what Fernando mentioned. On session start, you can inject additional context without overloading the system prompt. After stage edits, so basically run git add after the post tool use if it was edit. Context preservation across compaction, what Vlad mentioned. RTK command that we also mentioned, and there are like a lot of things that people use on the internet. So you go out and check what people recommend. One note on the security: the hooks are not sandboxed. I mean, it's pretty much the same as with Git hooks. It runs you with your permissions. So and it's possible to distribute hooks as a part of the plugins. So
watch out when you get
install,
started.
when you install a random plugin from the internet, you think twice.
Yeah,
because it's a sword which can hit you at the same time, because someone else can use the hooks and just exfiltrate the whole secrets.
It's the same with the supply chain attacks, like on PyPy and NPM, because, like, for instance, PyPy has, or like NPM, they have post-installation scripts, which like a hooks that runs with your permission, and people using them to abuse the system and try to exfiltrate credentials. It's kind of the same context here, so you should be very careful with it. Like, as I mentioned, it's not only a local bash, it could be calling HTTP endpoints. Well, you can even call like HTTP endpoints from the bash itself. So it doesn't really need to have to be a special kind of support for that. But something you run the hook, and that may be exfiltrating everything you're doing. So
or pull someone in your machine, for example.
Open the back door, basically.
I feel very wary of these marketplaces and all these GitHub repos because of that. So it's good. It's a very good reminder, right? Like to always check before you run any of this stuff.
The technology is very early. Security is afterthought. So like in the Wild West. If you like the Wild West, you should accept the risk that someone's gonna shoot you, because that's like the part of being in the Wild West. So it's the same here. You're on Frontier, and like on Frontier, different stuff happens to people.
True. Yeah. In our line of work, impact can be quite like, as a DevOps engineer, you might have a lot of access to production environments, and the impact can be quite destructive, right? So very good reminder.
Just a small plug. Next week, I believe that is, Vlad gonna be doing the webinar about the SSO elevator, the tools that actually reduces your access, and you don't need to have permanent production access. You can just get elevated access permissions for the temporary elevated access, and you can basically disable all access to production and just get on a needs-to basis temporarily, and then it will be automatically revoked. Vlad will be talking a lot about that next week. So look up his LinkedIn, connect with Vlad. You will see the details there.
All right.
Thank you, everyone. Talk later. Bye-bye.
See you in the next one. Bye.